Hello chemistry students, welcome to the week of March 23rd, lesson 2. Today we're going to be talking about Dalton's Law. Dalton's Law only involves pressure, so we're talking about adding and subtracting to find total and partial pressures today. Alright, this is John Dalton. In Dalton's Law, Dalton's equation, which is what we mean by Dalton's Law, the only variable is pressure. Pressure has to be in the same units. Before you can add and subtract money, you have to be all in dollars or all in euros or all in pesos, whatever the case might be. It's the same thing with Dalton's Law. And then this is Dalton's Law, number 3. Total pressure is the sum of each partial pressure. So you'll notice this is the equation that's on your notes page. It's on the back of your periodic table as well. It says P total pressure is equal to P1 plus P2 plus P3, ... So sometimes we could be talking about 6 pressures combined. Sometimes there would only be P1 and P2 because we're just talking about 2 gases combined. But you will notice sum means adding. We are adding and subtracting. Don't push multiply and divide for these types of equations. Alright, for Dalton's Law of partial pressure, we're talking about this visual. Okay, so in the same sized container, you'll notice the volume is constant, right? The amount of gas, space that the gas takes up hasn't changed. What we have is 0.6 moles of hydrogen exerting 2.9 atmospheres of pressure plus 7.2 atmospheres of helium pressure for a total of 10.1 atmospheres of pressure inside this container. So it's just a cumulative effect where we add the 2 pressures. Okay, so if we're talking about these being our first 3, canister 1, canister 2, canister 3, and thus being our total, okay, again, volume is constant, so pressure is the only variable, the only thing that's varying or changing. And if I ask you what's the total pressure of these 3 gases, it's as simple as saying 2 plus 1 plus 3 is 6 atmospheres. Okay. Conversely, we can ask you to solve for partial pressures. So I could say, you know, if the total pressure of these 3 gases is 6 atmospheres, and canister 1 is 2 atmospheres, canister 2 is 1 atmosphere, what's the partial pressure of canister 3? And then you'd say 6 minus 2 minus 1 equals 3. Okay? Talking about partial pressure in our regular atmosphere. Okay, so depending on sea level, right, we're talking about the air around us is 78.8% nitrogen, which makes up about 593.4 millimeters of mercury. And that varies from day to day. But that's our pressure. The pressure here from oxygen, okay, the pressure from argon in the air, the pressure from carbon dioxide. And there are other trace elements as well. But we'd say that adds up to our total atmospheric pressure of 760 mmHg. Okay. All right. I'm going to switch over to my document camera so we can work on these 4 practice problems. That's all we have left to talk about on today's lesson. Hi. Okay. So these are the first notes we took. If you're writing this down on your own notebook paper, that's what you should be writing down. Okay. And now we have these 4. So again, I'm going to take my not yellow class periodic table because I told you I didn't bring one from home. This first one, even though it doesn't say Dalton's Law, you would need to recognize this is Dalton's Law because he only deals with pressure. And there's our equation. Okay, so that's how we're going to be solving these. Let me grab all my markers for you. Okay, so boxing in your givens and circling your unknowns. Teachers are serious when we're asking you to do this. Okay, so this question says the total air pressure is 0.99 atmospheres. And I'm going to label that as my PT, like that, my pressure total. They told me that's the total air pressure. The partial pressure of carbon dioxide, so here's my first partial pressure, P1. The partial pressure of hydrogen sulfide is, okay, so there's another partial pressure. That's really hard to say, guys. What's the partial pressure of the remaining air? So they're asking me to solve for P3. Okay, so I found my givens, my unknowns. Here's my equation. So we're going to substitute. I know what my P total is on this question. They're not asking me to solve for the total. I know that the total is 0.99 atmospheres. Okay, so that's what I plugged in for my P total. and P1 0.05 plus P2 0.02 plus P3, which I'm just going to say is X. I don't know. Okay. We're going to combine like terms to solve for X. So I can go ahead and add these up to 0.07, and a letter is not a like term, so plus X equals still 0.99. The opposite of adding to X is subtracting, so minus 0.07 from both sides. Okay, gives us 0.92 atm. The remaining air accounts for most of the rest of the pressure. Okay. All right. Please box and circle 2, 3, and 4. Push pause if you think you can finish these without me walking you through it step by step. Push pause. Solve them all, and then check the answers. Okay. Question 2. A metal tank contains 3 gases: oxygen, helium, nitrogen. If the partial pressures in the tank are, okay, so they're telling me this is one of the partial pressures. This is from nitrogen, and this is the part of the pressure that's from helium. So they gave me P1, 2, and 3. They're asking me for total pressure. So they're asking me to solve for PT, or P total. So I've done my givens, my unknown. I know that this is still my equation, so we can substitute and solve. So for P total, I'm going to substitute in X. I don't know what that is. Plus P1, P2, P3. So 35 plus 5 plus 25. Okay, this problem requires no algebra because X is already by itself. So we just add them up. Okay, 35 plus 5 is 40. 40 plus 25, 65 atm. That's our total pressure. Okay, question 3. A scuba tank is often a trimix. It depends. I know some of you guys are actually scuba certified, but it depends on how deep you're going scuba diving, the depth that you're going to dive to, and which type of tank you're going to use. But trimix is a really common gas mixture for scuba tanks, and it's a mix of helium, oxygen, and nitrogen. They're asking me what is the pressure of just helium. So they're asking me to solve for one of the pressures, and I'm going to say P1 is what I'm solving for. If there is 0.39 atm of oxygen, so that's another part of the pressure, and 0.72 atm of nitrogen, that's another part of this pressure, and the total pressure of this tank is 1.5 atm, PT. So you need to make sure we're definitely getting the total pressure labeled correctly. So now, when I substitute and solve, I'm going to go green for this one, even though my colors aren't showing up well. My total pressure, 1.5, equals all 3 of them added together. So P1 is what I said was X, plus P2, which is oxygen, 0.39, plus P3, which is the nitrogen, 0.72. Okay. Again, pause it, solve it on your own, get a calculator. Mine, I'm pulling up my phone calculator app. Okay. So I want to combine like terms here. 0.39 plus 0.72 equals 1.11. So X plus 1.11 equals 1.5. The opposite of adding 1.11 would be subtracting. So that these guys cancel out and I have just X. I need to do that to both sides of my operation. So 1.5 minus 1.11 equals 0.39 atm. Okay. So far, all 3 of our units, and in fact even the 4th one, are atmospheres. But remember, you could also have mmHg. Let me pull this up so you can see that. mmHg is a unit of pressure, or kPa, and we would still add and subtract as normal, just like we do with atm. Okay. You'll notice that on your homework. It will use these other units as well. Okay, question 4. A container contains, that's redundant, a mixture of helium and argon gases. It contains 0.4 atm of helium. So that's not my total pressure, that's a part of the pressure. So we'll call that P1. The total pressure of the combined gases is 2 atm. So that one is my P total. What is the partial pressure of argon? So they're asking me to solve for the second part of the pressure. So my equation, I'm going to rewrite it, is total pressure equals the first gas plus the second gas in this case. So when I substitute, I'm going to substitute this that I've identified as my total pressure. 2 equals the first part, 0.40 plus x, what we're solving for in the second part. Now there are no like terms to combine, so I'm just going to do the opposite of adding 0.4, which is subtracting, so that cancels out, and I have x alone on this side of the equation. Subtract 0.40 on this side, 1.60. And the unit for that will be atmospheres, ATM. Okay. Please log on to Canvas and find the homework that goes with this. I think it's just 6 problems. Miss O'Brien has made a helpful video tutorial to help you walk through some of that homework if you need it. And then once you finish that homework, please enter your answers in as the Lesson 2 homework quiz. Alright, make sure you're looking for the end of the week quiz. It'll be open this Thursday through this Sunday. Thanks.